Last couple of months are the first time that I feel that AI is useful. So I was one of the AI haters, if you want to call it, right? Critic. Yeah, that's a better word. The muppet on a balcony. Now I feel that with AI, I'm acting more and more as a manager rather than developer, right? I still don't trust it. It cannot, most of the time, it almost never does everything 100% right.
Oh, welcome to Densify Talks. Thank you so much for joining us here on the podcast. My name is Brian. I am the producer of Densify Talks. Joining us today is technology critic and thought leader Viktor Farcic. Now, Viktor considers himself to be one of the critical old muppets in the balcony, if you've seen that. Viktor's experiences have led him to have some incredible knowledge and also opinions on much of the industry. Now, as we typically do here on Densify Talks, we try to give you a well-rounded amount of information to consume and apply. So today we will talk about the state of Kubernetes. Is it becoming boring? Viktor's experiences as a KubeCon guru, GitOps, optimizing via GitOps, and Viktor's opinion on Helm, thoughts on VPA, Densify's new Mutating Admission Controller, AI. Viktor is just now starting to like AI. He thinks it's still in that helpful but not good enough by itself phase. We'll talk about using things and, of course, resources correctly, Viktor's insight on what's coming in the future, and actually quite a bit more. So we're going to have a lot of fun today, a lot of information, so take notes. Hope you learn a lot today, and let's get right into it. Here's your host, CTO and co-founder of Densify, Andrew Hillier.
Thanks, Brian, and thanks everyone for joining us. Today I'm happy to be joined by Viktor Farcic. Viktor is a noted thought leader in the area of Kubernetes. Usually these podcasts are with our customers, but Viktor is not a customer. He's just an extremely interesting guy. Very opinionated, and I think you'll see that as we chat. He's an author. He also is a regular contributor to podcasts. So, Viktor, thanks for joining us today.
Oh, thank you for the privilege.
We were chatting, and you kind of likened yourself to one of those old muppets on the balcony that criticizes things when it comes to technology. So I think of you as a technology critic, and it's I think you have a lot of opinions on a lot of areas, and we'll try and get through as many of these as we can.
Yeah, I'm one of those. I'm one of the people that others dislike. Because I review their project or product or something like that.
And that's why we love you. I think even when we first interacted, you had all kinds of opinions and thoughts that were, of course, completely founded in the way technologies like ours should work. So let's dive in. I want to start with the recent industry events or general industry events. I think you and I were both at the London KubeCon, although unfortunately we didn't get to meet there. Salt Lake City before that. You do, it sounds like most, if not all, the KubeCons. How do they vary around the globe? How are they different, and which one's your favorite?
So US and Europe are big, above 10,000, something like that. While in Asia, China, Japan, and now India, they are smaller events, like 1,000 people or something like that. They're very different in size, very different in sponsors, very different in many aspects. I feel that those in Asia are more like KCDs, like big KCD rather than KubeCon, really. And I don't have an explanation, to be honest, because China before COVID, for example, was huge, massive. I don't know whether the interest disappeared or they're all coming to Europe or US or something else. I'm not sure.
And Europe almost, I'm not sure if it was bigger than the US, but it felt like a different event to me anyway. Do you know the sizes, if it actually was larger?
Yeah, if I'm not wrong, KubeCons in Europe are bigger than in US since COVID. And before COVID, it was the other way around. And I don't have the explanation for that one either. One theory is that in Europe, we are behind on tech. So maybe you know something in US that we don't in Europe.
I almost see the opposite. In some of our customers, I think a lot of the thought leadership in containers is coming out of Europe. It'd be interesting to dig into that a little more and understand why. Attending all these KubeCons, what are your thoughts on like the state of Kubernetes? Have they changed over time? Are they different now than they were in the early days?
Oh, they're definitely different, very different. I remember first 5, 6, 7 years of KubeCons, every time I would go there, I would be completely surprised with ideas that I haven't even thought were a problem or thought that this should be solved or thought that it could be solved in that way, right? In the past, I was always very, very surprised. I always left KubeCon with probably months of work just to get into everything I've seen. Now I think it's different. I think that Kubernetes is mature, and I think that now we're in consolidation phase, right? While in the past, we would, for every given problem, like let's say service mesh, we would get 10, 20, 30, 50 different solutions, all competing with different ideas how to solve a specific problem. Now we're more in a phase of, okay, so which one should we use really? Let's focus for a change. To me, that's a sign of maturity, right? It's not a hype anymore. It's not novelty that we don't know what it is. We're maturing, and that's usually contraction, not expansion.
From a solution perspective, everything's maturing. And I think that just goes hand in hand with the expansion of the use of Kubernetes. It's now so mainstream that people are just worried about making it work. And I think, I've personally seen a shift there in the maturation where, I spend a lot of my time describing, in the past, I described a lot of my time kind of evangelizing and describing the problem you're going to have with resources. Now I find, especially in London, I find that you don't need to kind of convince people that they're going to have this problem. They're aware of it, and they're saying, how do you fix it? How do you automate? What's your pricing? That kind of stuff. So it's great from our perspective in that people are kind of understanding things more and more. And to your point, it's maturing and becoming more mainstream. Now, I guess, with that, I guess my question for you is Kubernetes at some point going to become boring? Is it just going to become some really boring technology?
Depends how you define boring, right? It will stop being, or stopped already being novelty, right? Mm-hmm. It is still not boring because even though I think that we're in a consolidation phase of the projects, there are still quite a few companies that are still trying to figure out what it is, right? And that will continue for a while. Now, that number is shrinking. There is increased number of companies who are using it seriously, asking serious questions, having serious problems. But it's not yet boring. People are still discovering it, and there is a lot to discover there. What I'm more interested is, and I don't think that we reached that phase yet, is Kubernetes did not yet really expand beyond operation teams, right? You have typically, let's say, a company of a couple of thousand people, but there are 5 people who are really into Kubernetes and everybody else confused or not interested, honestly. Like if you're not JS developer, do you really want to spend 7 years learning Kubernetes? You don't, probably. If you do, then you will stop thinking about Node.js and become Kubernetes ninja. I feel that that's one of the big unsolved things, and that's how to make Kubernetes boring from the perspective of you don't really necessarily need to dig deep into Kubernetes to use it, right? You can just consume service on top of Kubernetes that will give you what you need, or let's say call it right level of abstraction, because Kubernetes is very low level. You deal with deployments, services, pods, what's not, and we're still missing that layer on top that will make it similarly useful to developers as, let's say, AWS is to operators.
Yeah, I think this has come up in previous podcasts I've done where, I mentioned we've seen this kind of pattern before with VMware, or even with cloud, where in the early days, it's a bunch of gurus that really understand it well, kind of leading the charge. But then eventually it has to be manageable by people that aren't gurus and aren't experts. And recently, I think on the previous podcast I did, we talked about this, where in the app teams, let me just step back for a second. I view that Kubernetes can be both an infrastructure construct and an app deployment construct, which are kind of two different things. And so if you think about it like a hosting environment, you view it one way. If you think of it as a way to get your code out, it's different. And I think there are fewer and fewer infrastructure folks that understand it from that perspective, as opposed to people that use it for app deployments. So as it grows, more and more people are using it just to deploy apps, but don't necessarily understand the mechanics of the resourcing and scheduling. Like you said, it's a very low level technology. And I assume you're seeing that trend too, where there's just kind of more and more people just want it to work.
To put it a different way, I think that 2 things will be happening, or are already happening, is that providers will be giving you services on top of Kubernetes without you even necessarily knowing that there is Kubernetes behind it. Like a good example would be Azure Container Apps. Hey, here's my image. It works very similarly to Heroku, right? Here's my image, run it. And just it happens to use Kubernetes behind the scenes. And the other scenario is where all those Kubernetes experts, ninjas, and experts in databases and security and what's not will be creating services on top of Kubernetes that people consume, right? That would be custom resource definitions, custom controllers, basically creating that layer that is specific to their organization and in a way abstracts Kubernetes from people who are not focused on Kubernetes or experts in Kubernetes. I'm an old guy, you're as well. even though we cannot see each other. You remember like in the past when if you wanted a PC, you would go to a shop and then you would buy a box, you would buy a hard drive, you would buy memory, you would buy CPU, you would assemble it all and you would have a PC, right?
Mm-hmm.
We don't do that anymore, unless you're very gaming enthusiast or something like that. I want that for Kubernetes, for the end users. Somebody needs to know what's happening inside, but not everybody.
Yeah, it's almost like all the problems need to be solved as we mature along the way until it just works and the technology's kind of sunken down deeper underneath the covers and you're just using something that works. I think we're getting there as far as when those new innovative approaches come out, it takes a bit of time to understand the pros and cons and how they work, and then they just become mainstream operational components. So it's like a PC. Yeah, there used to be the days where you put on the anti-static wrist guard and try and put the memory on the board. Yeah, I don't know when the last time that happened, unless you're building a liquid-cooled PC gaming machine. And we focus at Densify on the resourcing side of it, which is interesting because it is still there's some very raw constructs there. Every consumer of resources has to give requests and limits. We're finding, of course, that creates a bit of a mess if you do that wrong, and it is hard to do it right. And we were talking the other day about this. About, we see people wanting to solve that through things like GitOps. We have a Terraform module that will update your settings automatically, fix the values. And I brought up something, and it really it became an interesting discussion because I mentioned the word Helm, and I mentioned you're opinionated. And when I mentioned the word Helm, you had a lot of thoughts on this. So what are your thoughts on Helm and the current state of that in the industry?
Helm is, a lot of people will get mad at me. Is the worst solution we have for creating templates, simply because the output of Helm is structured data in YAML format or JSON, right? And Helm is the only solution that is completely unaware that we're using data, right? That we are working with data. I could just as well use Helm to construct a Helm HTML web page as to generate data that is submitted to the API. So I don't have anything against Helm in terms of using it as a way to install stuff or upgrade stuff, things like that. I'm just very negative towards the Go templating used in Helm. I feel that KCL is better, YTT is better, Q is better, anything is better, really. When I say that, I just want to make clear that I am all the time talking about how do you define what you need for yourself. I'm not referencing third-party charts, right, or applications or whatever we're installing, because I don't care about all the complexity of managing Helm templates when I just install PostgreSQL database through a Helm chart. I'm just using Helm install, works well, nothing against it. I just don't want to use it for my stuff.
And it does still become difficult to figure out what can be customized and what shouldn't be in those charts. I think it's still kind of it's just a big blob of information. And it is back to your initial thing about it being it's a pretty raw technology. So if you saw this becoming very mainstream and people just want Kubernetes to work, it's hard to envision somebody having to write a Helm chart just with the average knowledge that's out there. But to your point, if you can just consume that already exists, that's fine.
Oh, yeah. And it's normal. I think that happens with every single technology that is a pioneer of sorts, right? I could say the same critique, not the same, but critique of Mesos, right? Mesos, nobody should ever use Mesos, right? And it's not that engineers behind Mesos were bad and didn't know what they were doing. It's just that it was the first of its kind. And then we got newer technologies. We got Docker Swarm, we got Nomad, we got Kubernetes. And all those projects actually took the lessons learned from Mesos and avoided some of the pitfalls that Mesos had, mainly because it was the first. And Helm was also the first. That's the problem.
So it has a path to follow to improve over time. Back to the GitOps discussion. So you're using these technologies, they're in a repo. Of course, if we want to automate the correction of the resource specifications, which is our focus, it becomes very difficult to figure out how to do that in a repo because every repo is different and the structure is different and the files are different. And we see some approaches where they try to use AI to go through the repo and find where do I find that request that's defining that container. It seems wildly complicated. And what are your thoughts on that? I mean, the whole GitOps as a method of optimization and AI, do you think that would work?
So let me start by saying that, yeah, I'm a huge fan of GitOps. It's not perfect. I think it's just better than what we were doing before. But I use GitOps in a very different way than most other people. I don't have Helm charts in my Git repo. I use tools like Helm because they're easier, and I'm using Helm as example. They're easier to define complex logic that will result in static definitions of something. I always use Helm template to output YAML, and that's what I store in Git, right? My Argo CD or Flux, whichever I'm using, is working with pure YAML. And I think that that's important for two reasons. First, because it's easier for them to understand what needs to be done instead of doing the templating themselves. But more important, because one of the benefits of GitOps is that we have the desired state that a human can take a look at and see what the intention was. Now, if I need to go through some kind of templating, or let's say it's not Helm, let's say Go or Python or whatever somebody defined, I need to do mental calculation. What did the author think with all those ifs and conditionals and values extrapolation? I cannot figure out by looking at the Helm chart what the desired state is. So for me, GitOps is pure declarative format YAML most of the time.
What you say makes complete sense. But if I want to correct a resource specification that's coming out of one of these files, I need to know what file that, like if we want to do kind of a shift left automation and say that container needs to have more resources, it becomes very challenging to do it back in the repo because you don't even know where that's coming from in the repo. Because as you point out, you do it differently than the next guy. So I was just asking you if you think there's a way that could be done where you can reliably figure out how to find stuff in those repos based on the templates.
I think that the key is when you said reliably, right? I haven't seen anybody succeeding to do that simply because the number of permutations of what one can keep in Git is close to infinite. We would all need to agree on the structure, right? Which is not likely to happen. I don't know how to do it. I haven't seen anybody doing it successfully. AI is not an option in my head today. It might be in the future. And the reason is that when we deal with things, right, with resources, it's very important that we are very, very precise, right? There's a huge difference whether you use correct image or not, right? Whether you define, I don't know, deployment or a stateful set, whether you use S3 buckets or you use some other storage. I don't think that AI is still at the level that is, let's say, reliably correct in, let's say, 99% of the cases. What I would be willing to accept is some kind of AI involvement that still requires final confirmation from me. So, for example, if that AI would make changes, let's say to resources assigned to memory, CPU, or whatever assigned to resources, and create a pull request, and then I go and check whether that's really correct, then yeah, maybe.
As a co-pilot or something that's helping you, but not something that's doing it for you. And I agree 100% on your comment on precision. It's like you wouldn't deploy something in the pipeline with the completely wrong version, but people tend to deploy it with the completely wrong resource specification, like a limit that's too low that will cause it to get killed. And yet, that's treated differently than everything should be very precise in that pipeline, and it should all just be correct.
Exactly. And that's why also we rely heavily on automation, right? Once you figure out, let's say, that application or infrastructure or whatever you're managing, you're most likely not going to change anything but the image over time, or maybe the version of that something, right? Once we figure it out, we rarely change things unless there is a very good reason for it.
Yeah, there needs to be, and we had this discussion around, and I think that's one of the advantages of technology like crossplane, where I want to separate the things that should almost never change. Like your port number is just your port number, from the things that'll likely change quite quickly, like your resource requests. Your app's growing, you need more resources, and to have them all lumped together in one spec is doesn't make a lot of sense. Some of them are much more dynamic and mutable than others. And so
exactly,
I see that as the advantage of crossplane over something like Terraform. And I see that also being kind of key in the container world with these templates.
Yeah. The whole idea is really to expose to people things that matter, things that change. Convert everything else as implementation detail, no matter which technology you use.
Yeah, that makes complete sense. So in London, I mentioned we didn't have a chance to meet up. If you had to come by our booth, we were showing off our new Mutating Admission Controller, which is an automation component that can just dynamically change the requests and limits of the containers as they're deployed. And we see that as a really good way, as opposed to trying to get upstream to all these repos and figure out where things are. Just fix it as it's deployed, because people, like we talked about, these values should be muted, mutatable, or mutable, I should say, as operational conditions change. Now, the other thing we see out there that's kind of similar to that is VPA, but we don't see a lot of people using VPA, which its goal is also to kind of change the sizes of things. But what are your thoughts on that? We see that as we can be a recommender to VPA, so which is kind of great, but we don't see VPA out there very much. Do you have any thoughts on that or any observations?
Yeah, it's not commonly used for many reasons. First, I think that VPA does not get as much love in the community or among vendors as HPA. When I say HPA or VPA, I don't mean necessarily vertical pod autoscaler, but vertical or horizontal scaling. It's not getting enough love. But more important reason is that those two simply don't work together. And then we are in a very strange situation. And that situation is that, let's face it, nobody knows how much memory and CPU and other resources applications need. I never met that person. I met people who confidently say that they know, but I never met people who really actually do know, right? So we need some kind of vertical scaling, something that will assign correct amount of resources. But on the other hand, if you go for vertical scaling, which cannot be combined with horizontal scaling, then we're losing equally important or even more important aspect, and that's horizontal scaling, right? We don't just grow a single replica of application to infinity. We scale horizontally for many different reasons. And inability to combine those two without breaking everything is really a problem, right? And probably the reason why so many people say, okay, if I can focus on only one of those two, then yeah, I'm going with HPA, and I will pray to the deity of choice that I set memory and CPU correctly.
It's odd that people are forced to pick, and we see that as well, where if you had to pick one, you'd pick HPA, because that's the fundamental construct of elasticity, right? Otherwise, you're just running stuff big all the time. And we've seen that exact problem where if VPA scales the metric that HPA is using to scale on, then HPA will just scale out uncontrollably. So you'll get into kind of this scaling loop. And we've seen that happen. We've seen products cause that to happen. So you'll be happy to know in our Mutating Admission Controller is pretty smart. It avoids that. It actually understands what HPA is doing and won't touch the metric that HPA is scaling on, because we still see, to your point, we see people just choosing memory and CPU resources, hoping they're correct, and then running these hugely scaled out environments with hundreds of replicas, and it's just chewing up hundreds and hundreds of CPUs and gigabytes of memory. So it is back to that problem. It's a big problem. VPA, unfortunately, wasn't smart enough to work with HPA. I think we're quite happy that our new admission controller can do that, and I think that's going to unlock. Not to make this an advertisement for our new admission controller, but we felt that, I agree with you, that's a big problem, and we saw that as a problem, and that's what we attempted to solve with our new admission controller.
I think that's the correct direction, because I feel that it's been decades since we were trying to figure out how can humans tell machines how much memory and CPU they need. And maybe actually we were on the wrong path all the time. Maybe we shouldn't be dealing with those things at all. I'm talking about far away future, right? Maybe I shouldn't even try to specify how much memory, CPU, what's or not something needs, and just let the system deal with it, right? And I understand that we need an intermediary period where I take a look, recommendations, and see what I was supposed to do even though I didn't, and then adjust, and so on and so forth. But once we start getting confidence in the system, I kind of hope that the system will just figure it out. I hope to see the future in which actually there is no option to specify memory and CPU.
Yep. And we've seen some customers take that approach with our Terraform module, where they say, we're not letting the users specify this. The machine is going to figure it out, because you're absolutely right. The machine is far more qualified to figure out what it needs, especially because Kubernetes is a really complicated system with a lot of different workloads from different users. You don't know what everybody else is doing in this. You don't know if putting your request below your peak is going to be fine, or it's going to cause a problem because everybody else peaks at the same time. Like it's something you can't know as a consumer. So I would say that the machine, you have to leave it to the analytics and the machine and the infrastructure to just sort it out for you. And eventually, hopefully, that's just all automatic for everybody.
The bigger problem is that we're still used to the previous era where most of systems were relatively static, right? Now everything is dynamic. So even if I do figure out how much resources something needs, that can be valid for 5 seconds. Right? So I'm going to spend all my time trying to fine-tune it only to be proven wrong a bit later. 5 minutes or 1 day or 1 week or whatever. Things change all the time. I can be precise in things that don't change. I don't see how I can be precise. Unless actually you hire me to just constantly type megabytes and CPUs, kind of. That would be my job, right?
Yep. Or let the machine do that for you and kind of try and predict where things are going to be to get it right so that you're always ready to scale when you need to. Yeah, and it's ironic because in all of this, I find, and sometimes I get in these discussions around Kubernetes versus, the legacy VMware environments. And I think they did a slightly better job because they had an overcommit model that meant I can get it somewhat wrong because centrally I can just give out the resources more than once. I'm giving it virtual CPUs and virtual memory. So if I gave too many to you, I can also give the same CPUs to somebody else, and then I can just watch the system and make sure it's not getting too loaded. Whereas in Kubernetes, you kind of lost that ability. I literally have to give you the CPUs that you requested. I need to allocate them on the floor or in the cloud. And it makes it much more rigid and I think much more important to get it right because you can't fudge your way out of it later by just cranking up the overcommit. It doesn't work that way. And I think people don't realize that when they first go into Kubernetes, that it's not going to magically overcommit and share resources. You still have to get the numbers right going into it.
Oh, people are very aware of that, I believe. That's why they put 5 times more than what they need.
Yeah. It manifests itself as 5 times more, which means it's 5 times more cost than you need. And that's exactly what we see when you go and analyze an environment that oh my God.
It's even worse. It's 5 times more than what I guess might be the value.
Yeah. And we see some pretty crazy things. And it ends up being, this massive line item on your cloud bill. We have a huge scale group or a bunch of instances that aren't doing very much. They're used like 7% or 8%. And it's endemic. It's everywhere. And I think that's the frontier that people are kind of realizing needs to be addressed. And, as evidenced by the booth traffic in London, where there's a lot of nodding when you get in. People are aware of this problem now, I think.
And then you hear stories about people realizing that cloud is too expensive. They're going to build their own data center.
Repatriation.
It's too expensive for me to use 5 times more than what I need. So I'm going back.
Yeah, we're hearing a lot about that too, and it's in some cases it makes sense, and it's kind of a funny trend because I think cloud evolved to be pretty expensive in the end, especially if you're paying for stuff and not using it, which I think is the case here.
And of course, it's expensive. I mean, the same. If I buy 5 cars and drive only one, of course, I'm going to spend much more money than I need.
Yeah.
But it's not the problem. The price of the car is not the problem in that scenario, right? It's me buying 5 of them.
Yeah, exactly. And we take the same approach. You can get your rate discounts optimized all you want, but if you're using twice as much or 5 times as much as you should be, you're always going to have a cost problem. It's just that simple. Now, Viktor, on the cost front, the last thing I wanted to talk about, which we seem to always pivot to this topic lately, is AI. Because of course, the cost equation goes through the roof when you start adding GPUs into the picture. What are your thoughts on that, AI and AI in Kubernetes?
The last couple of months are the first time that I feel that AI is useful. So I was one of the AI haters, if you want to call it, right? Critic. Yeah, that's a better word. The muppet on a balcony. AI is now, with emergence of agents and MCPs, I think that those 3 finally make sense. That it's not only LLM, which acts as a massive Wikipedia, but agents that are capable of doing something, and MCPs that are capable to provide the context that those agents need. So now I feel that with AI, I'm acting more and more as a manager rather than developer, right? I still don't trust it. It cannot, most of the time, it almost never does everything 100% right, but it does help me to get to some point faster, right? So I feel that I'm using AI in a similar way that when I was working in the past with junior developers, right? Or engineers, and kind of, hey, it would be nice if you can do this, but don't push it directly to the main line. I need to see that PR. I need to check what you did, right? Which is improvement. Now, where it will go, I think that nobody can predict. But probably the biggest problem I have with AI right now, unlike humans, unlike us, it is still not good at learning. Every time you start a new session, you're starting from scratch. And I know that you can give some instructions depending on which AI you're using, kind of, always do this, I'll always do that. But what I'm ultimately looking for is a future variation of AI that will record and remember everything we did, right? Just as a human would do, so that it doesn't repeat the same mistakes and eventually, gets better over time. Right now, unless I upgrade it to newer version of agent or LLM or what's not, tomorrow it's not going to be any better than it is today.
So you're almost talking about less of a rigid transition from learning to inference. You're saying you're either training it or you're using it, which we see a lot of right now. And we see a lot of inference on Kubernetes happening. And you're saying don't make that distinction, let it blend it together so the thing is always learning.
Yes, maintain some kind of internal memory, internal database, whatever you want to call it, so that everything we did so far, you know about it and you don't repeat the same mistakes. Because otherwise, and I see that a lot in, let's say, observability, right? That the AI is entering that area. And then you have a situation that, hey, it detected the error, same issue that it detected yesterday and the day before that. And in all those cases, you realize, it's Jenkins, right? We need to restart it every day. We know it's not a problem, kind of. That's how it works, right? But you don't know that if you haven't memorized what you experienced with it previous day.
It's like that movie 50 First Dates, I think it was called, where every morning he's reset.
Yeah.
Or Groundhog Day. That's
Groundhog, yes.
Concept. Yes, that's probably a better analogy. And as far as, so we do see now, in our customers, them deploying, even products that carry an LLM with them and need GPUs to run, what they're going to run. And it's probably, like you say, it's probably not learning anymore. It's just kind of leveraging, but just using a model to get answers out of the thing. I think that's going to start to create an even bigger cost problem because, again, these GPUs are so expensive. If they're sitting around idle or not used very much, like think of what it'll do to the cost compared to even just Kubernetes today with the things 5 times bigger. What are your thoughts on that? Do you see a whole lot of cost in the Kubernetes environments because of these GPU node groups?
It's a huge cost, and yet another even bigger example of how actually cloud makes so much more sense if you use things right? Because what are my options? I can buy 100 GPUs myself, or I can rent it from AWS, Azure, what's or not, knowing that, hey, right now I need 0. And an hour from now I need 1. And tomorrow I will need 50. Being able to ask, and I feel that that's the same thing like memory and CPU we were discussing earlier, just now it's more expensive. The ability to use what you need and not more, that's critical, right? Especially when things are so expensive. And I still see people, hey, I assigned how much GPU this needs, and especially for inference, and if nobody's using it, what can you do?
Yeah, we view it as a yield problem. If you have these things turned on, you want to be using them or turn them off, because if they're sitting around idle, that's just crazy. Now, the challenge we've seen, and I don't know if it's getting better lately, is that you maybe can't get them when you want them because there's a shortage of them, so people will hoard them. So we've actually seen cases where people just grab all the GPUs they need, because if they know they're going to need them tomorrow morning at 9 a.m., they're not guaranteed to get them when they go to turn them on. So there's a bit of a cloud supply and demand problem that hopefully is being addressed, but I'm sure it still is. Just to be safe, you probably want to hold on to them.
I think it's temporary, because there's nothing that a cloud provider wants more than to sell you usage of something. If anybody is going to get hands on those GPUs, is actually cloud providers rather than you in your own data center.
Yeah.
Precisely because of the purchasing power that they have. So I could probably change your statement into, hey, because of that happening, you are even less likely to be able to buy it yourself, physical GPU.
And it follows that same path. I find it kind of ironic that cloud in the early days promises elasticity and pay for what you use. Oh, but wait, if you commit, you'll get a cheaper value. So, of course, everybody just moves to being committed to it, and it looks a lot like before. And now, the same thing happening with GPUs.
I feel that those are different things, right? I can get better price from AWS or whichever provider I'm using by committing to a certain amount of compute, whatever that compute is. That does not mean that I shouldn't use it in a most optimal way, right? Because if I scale up and down my workloads, no matter whether they're AI or something else, and change how much resources I use, then actually I can commit to a smaller amount and get the same effect.
And also we see people not committing to their full usage, so there's still some elasticity downward because you don't want to be locked in if you want to start using less resources for some reason over time, like if you optimize. So yeah, really, again, we have a lot of discussions with our customers around that and committed use discounts and how to optimize that based on. But the biggest problem is you should base it on what you actually need, not what you're currently using. Because back to that 5x thing, if you're running on 5 times the infrastructure you should be because your settings are all wrong, you definitely don't want to lock into that as your spend commitment. But that's exactly, I think, what people have to do because they haven't optimized their workloads.
Well, it depends. Maybe people are very rich. They can afford it. Why not?
Yep.
I would buy those 5 cars I mentioned earlier if I would have money.
Yeah, well, I was making the argument, scaling only exists to save money because if you didn't want to save money, you just leave everything big all the time. And
exactly.
VPA only exists, or vertical scaling, leave everything big, leave all your HPA scaled out because the only reason you make it smaller is to save money, which is exactly the point of all of these structures. But if you're not using them to do that, you're not using them properly because that's what the elasticity should be doing, is not paying for stuff that you don't need.
And then you have a company that needs to cut costs and then fires people instead of reducing resource usage.
Right, because they're stuck with the configuration.
It's the same money.
Yep, it is. So Victor, any other parting thoughts? Anything? Where do you see things going? What if you look at, I don't know, the next KubeCon or 2 KubeCons from now? What do you think is going to happen there? Is it going to be different again?
I think that the main focus is right now, of course, AI, because everybody's crazy about AI. Mm-hmm. I don't see the story, neither the demand nor solutions for platform engineering dropping anytime soon. I think that that's the next phase. Because if you think about it, really, if we manage to reach the point where almost every company uses Kubernetes, that's great. First milestone. The next milestone must be that everybody in that company uses Kubernetes. And the only way to do it is to actually not force everybody to spend 7 years learning it. Some form of platform engineering, and that can have many forms. And I think it includes almost every technology available in Kubernetes right now. So it's more about how to combine all that. And that includes resource optimization as well. We'll have to get some different shape. So I expect to see much focus. Probably biggest focus will be that in years to come.
Yeah, make it ready for the mainstream. And I used the word boring earlier, but in a good way. It just works. It does what you need it to do. And you don't need to have a PhD in Kubernetes to get your application going. You can just get on with it and focus on the business value. I agree. I think that would be a great future.
Yeah, somebody will always have to have PhD in Kubernetes. Just as there are still people who understand hypervisors, even though 99% of us don't anymore, right?
Yep.
Somebody does, but that should be a small number of people.
They can make it work for the rest of us.
Exactly.
Victor, thanks for joining us today. I really enjoyed the discussion. As always, you have some interesting perspectives and opinions on things, and thanks for joining us today.
Andrew Hillier and Viktor Farcic, thank you both so much. I've got to be honest, I really enjoyed that discussion. It was great. So thank you. My name is Brian, producer of Densify Talks. And thank you, by the way, for listening and joining us here on the podcast. We really appreciate you being a part of this. Make sure to subscribe so that you do not miss out on any episodes coming your way. We've got a bunch more coming. And we've got some fun guests coming as well with a lot of great information. Of course, we'd love to hear from you, by the way. Densify.com, marketing@densify.com. If you have questions or if you'd like to be on the show, feel free to email us. We'd love to hear from you. But thank you so much for joining us here on Densify Talks. Have a fantastic day. We'll join you on the next episode, and we are signing off.